Hello, and welcome to the next lesson, case study number 14, Intelligent Knowledge Search. Let's get started. Lyla is a small business owner who wants to create a chatbot for her employees. This chatbot will help them ask questions and find answers from the company's internal knowledge base. Lyla believes that the chatbot will make it easier for employees to access information like policies, guidelines, and training materials. Lyla aims to build the system to help them work more efficiently and spend less time searching for answers. Here are the requirements. The chatbot should answer natural language questions accurately using the company's knowledge base. It must provide concise and relevant responses tailored to user queries. The system should integrate smoothly with the existing knowledge base for easy access to data. Strong security features are necessary to protect sensitive information, including user authentication and access controls. The chatbot must be scalable to handle more queries as the company grows. All right, now, so let's go into design. And like always, we start with the user. Now, we're going to see a combination of a number of things that we've encountered in previous case studies to form intelligent knowledge search system. So first, let's go with the web service that we usually interface with, the user usually interfaces with. So we'll go ahead and hold on one second. Let's go ahead and put this over here. And then again, we mentioned that there should be strong security features necessary to protect sensitive information. You know, when you hear about that, of course, that means that we're going to have our user authentication service as well. So I'm going to put user authentication service over here as the first element that they interface with. I'm going to put this here in front of the user. I'm going to put the service a little bit over here for a reason. We'll talk about that in a little bit. But first, the idea is that the chatbot should answer natural language questions accurately, right? So we know that what we want to have is some sort of AI model to be able to understand language and also to be able to respond appropriately. We saw this in paradigm in the chatbot that we did earlier. So in this case, we're going to do the same thing again. We're going to combine two AI models, one that is focused on natural language processing to understand, and one that's focused on the response back to the user. So let's go ahead and do that. So for here, we'll have a service. And remember, AI models are, at the end of the day, a file full of matrices. So that's why we have a file store here. We call this the NLP service, our natural language processing service. All right, so let's go ahead here. I'm going to, again, leave a little bit of space because there's some other things coming up. But then also, just as we've done in the past, we actually have another service backed by a key value store. Let me align that a little bit. And this, actually, I think I can extend this to be on one line. I like that. Will be our response generation service. So again, one AI model focused on understanding the response, one AI model focused on giving a response to the user so that in a way that they can understand. Right now, note though, it says, both of them, that says using the company's knowledge base. And then you hear about essentially, the system should integrate smoothly with the existing knowledge base for easy access to data. And you hear things that means that these elements, both the natural language, the NLP service, and then the response generation service, needs to have ready access to the entire knowledge base. Now, going off and clicking the internet every time somebody does a response is not scalable, right? So there are a number of ways to achieve this. One thing that we've taught in this set of videos, a set of case studies, is that we have this ability to put information into vector space and put it into a vector database and have our AI models have access to it as people are querying it. And that gives the ability for queries and queries to understand and to respond to, the ability to understand and have access to the knowledge base of the system, of the company. And it's really powerful because it takes there's a difference between creating a model that takes lots of training, and then you get to training and it takes a lot of output in order to get a single file that has like the knowledge of petabytes and petabytes of data that's being processed, as opposed to a knowledge base that continuously changes, continuously grows. But you can't train a new model every time somebody adds a new piece of information. So as we taught in earlier, a vector database is really key to this, because you can just like in a relational database, add new information into a vector database, but also do it in a way, convert it into a format that's similar to the weights that are found in models, so that models can actually use that to search and understand what what you're trying to ask based on the knowledge that the company has in the knowledge base, and also see what the query that somebody's asking is similar to documents or what have you that's in the company knowledge base. So that's why we actually have a vector database here. We're going to call this the knowledge base vector database. Again, the goal here is not to have the best names here, but I want to have the most obviously descriptive names so you know exactly what it's doing and what the purpose is. And these will be connected to these two AI model services. So let's connect a few things together here just to make this clear. So both, and this is the other that's key, both the natural language process service has access to knowledge base, because you want people to be able to say things that might be company lingo or what have you. You want to be able to understand in the context of the company. But then you also, of course, want to respond and make sure that you're getting the responses. The response has the understanding of the company knowledge base inside of it as well. This is what's really important. Now, as of course, as we've seen in previous case studies, especially if you want scalability, which is, the chat must be scalable to handle more queries as the company grows. Understand that anytime you have a query to a AI model, it takes computation time. It takes significant computation of time. Some of these are powered by GPUs instead of, in order to be able to respond in a timely fashion. So we want to put this behind something that enables us to make sure that we don't overload the system. And one of the key paradigms is this is when you add a queue with some workers in front of this system. We've done this before. I'm going to call this the user request service. All right. And what this does is that when somebody goes in and sends a message and say like, hey, I have this is a question I have of that I want to get information from the company knowledge base, it fires off a queue, and a worker goes through and talks the NLP service, talks to response generation service, cuts back the information to the user, so that people are able to still respond to interact with the system, and the processing that it takes to do so does not hamper the user experience. And yes, let's say if there's too many workers for what we have spun up, then you can have the user like, oh, hey, this system is working, it's overloaded at the moment, please, wait later. We can give a nice error message to set the expectations of the user. And we also have a system that we don't have to continuously scale up in order to meet user demand. So this is, queue again with workers are one way of handling scalability and spikes like that. So we have this, and before I draw a line, there's one more thing that we can do. So again, this is one aspect that we can do to make sure we don't overload our AI models and their processing time. Another thing, again, we've done this in so many case studies now, is caching, right? So there are going to be times where there's a search term that is searched often, maybe something that's newly introduced in a company that everybody might be searching at the same time. If we have some version of a cache, we'll have the ability to serve those results without having to reprocess it again. So, and what we know is that caches are best suited for a service that's backed by some sort of storage building block that is optimized for speed and retrieval of data. And the key value store is the best suited for that task. So I'm going to have this here. Hold on. So, there's like a train going on. So let me go ahead and move this over here. Let me reorganize things a little bit. I'm going to make this a little smaller. And I'm going to copy this. And this is what I'm going to call the high frequency search term cache. Long name, but you understand what the idea is. Like high frequency, like people are really searching this term. We'll save it there so that if it's there, it just gets served from this aspect and doesn't have to go through the entire system. And so now let's connect some dots. So the user goes, authenticates to make sure that the user should have access to this. It searches the high frequency search term cache. Is the cache there? Is whatever they search there? If it is, it sends it back. If not, it keeps going to the main service that provides the functionality. If they do have a thing that they send off that's not in the cache, it creates a request, a worker that goes into the natural language process to understand what the user wants and needs. That's connected to the knowledge base so that we understand in context of the company information what they're asking for. And then we have a response. We go ahead, we use the response generation service to respond in natural language using a company knowledge base. So we can not only just send a response in natural language, but we can send a response with company understanding. So you can think of like, maybe it'll bring like the acronyms that the company might have, or put that in the response and so on and so forth. So we have that contextual response, and then so we send that back to the user. So here we have like a really great system, right? That it enables us to go ahead and search and to ask this system natural language questions, and it has a knowledge base in order to be able to grab that information from and send it to the user. So we actually hit in a number of these requirements already: the natural language question, concise and relevant responses, that's a response generation service. So integrate smoothly with existing knowledge base. That's what we have here. Strong security features necessary for sensitive information, and must be scalable. It's the third requirement we're not fully there yet, because there's an existing knowledge base, and we can just assume that it's not naturally sitting in a nicely manicured vector database ready to be plugged in. So what we can assume is that we have some external service or some external area, and we're going to just call this, for lack of better, just for clarity, company intranet. I mean, if you're in a company, they have an intranet, or they may have a wiki or stuff all over, in a bunch of places. We're going to represent it as this external service cloud. That's where the data is. The idea is that we need to get the information from here to here. That's the thing that's going to be interesting. How do we do this? There's two ways that we access this. So first, we want to be able to have a regular periodic process that crawls the company intranet for new information. We'll call these web crawling workers. And what these do is that they go ahead and they access the company intranet, crawl it, get information, and then this is what populates or updates the knowledge-based vector database. So as the company as it crawls, it goes ahead and understands like, oh, okay, so this new page and what have you, and eventually continues to update the knowledge-based vector database so that this is actually up to date with what's in the company intranet. Now, if you ever post a website and so on and so forth, this is great, but if the crawler didn't get to like the new piece of information that may be really important, that might end up being a problem. Like, you may actually want a mechanism to have the web crawlers crawl this site, sooner rather than later. So in combination of this, of the web crawling workers, I should plural that, we also have a service connected to a queue. All right, I'm going to call this a knowledge base submit queue service. hold on, and let me just move this up a little bit so that the name can fit. All right. And to enable the user once authenticated, right? Okay, let me see if I can make this look good. Okay, there we go. Once authenticated, can go ahead and say like, oh, I know there's this area in the company intranet. This is the URL. I submit that, right? And then this would submit, and this will go into also these web crawling workers, and then that will trigger a worker to go to the company intranet and crawl that maybe faster than it would on its own. But at the end of the day, these web crawling workers are the main element that populates this knowledge-based vector database, which gives this whole this whole intelligence knowledge search system the context it needs in order to respond to to employees' questions about the company and what have you. And that is our system. Let's go to our key takeaways. First key takeaway: the system needs an effective way to gather data from its knowledge base regularly, both new and old. To enable the AI models to query for semantic meaning, web crawling workers periodically search the company intranet and populate the knowledge-based vector database to provide the NLP service and the response generation service access to the company intranet as vectors. Second key takeaway: natural language processing helps an AI model understand questions and find answers naturally. The knowledge-based vector database filled with company intranet data allows the AI model to locate documents related to a query. It does this by linking the sentiment of queries to specific documents that can answer those queries. Third key takeaway: again, we use the high-frequency search term cache to cache frequently asked questions to return those results more quickly. Especially in a company environment, there may be a highly likelihood that everyone in the company is searching or asking the same thing. You can also use this feature intentionally and tell everyone to the company to look up new feature, and new feature would be stored in the high-frequency search term cache and not tax the system. Thank you so much. I'll see you at the next one.